Okay, welcome back. We just finished creating ourselves a new user, and hey, let's see if we can create a group. Okay, now we know we just created a group. We created a group called Bob, but we're going to create another one. So if a secondary, and I haven't really explained what that means yet, so just bear with me. A secondary group called sales. All right. So if the other one was add user, what do you think the group one's going to be? Is it going to be add group? No, it's going to be group add. Hey, I never said these guys were consistent. Okay. So add group. Oh man. Actually, you know, I was expecting it just to come back and say you can't do that. It was not. Whoa. It helps you spell sudo correctly. Okay. So now if I do ls, well, hang on. Let's do less on etc. groups. Whoop, group singular. And so somewhere in here should be sales. Yay! Okay, cool. So I've created a sales group. Does that mean anyone's in the sales group? Well, you can kind of sort of tell, because if somebody was in that group, it would have been there. All right, let's look at this. Let's look at where I appear in here. So I'm part of the sudo group. That's very handy because it provides me permission for doing sudo commands. I'm in the dip group, which probably describes me very accurately. I'm in the plug dev group. I'm in the LXD group, and that's it. Okay, cool. So if I want to do change somebody's group, so I added him into the system, but I want to change Bob's group. His default group, his primary group is Bob, but I want to change it. So I'm going to say user mod. Oh, you know darn well. Dang it. User mod minus capital G. Okay, that's a little odd, because they make a distinction between G being group and G being a primary group or secondary group. So sales Bob. Okay, so now if I do that less command, I'm going to do bang LES, right? And so now sales has Bob in it. Yay! Cool. All right, that's how you add people to a group. Okay, so you learned how to build a group, and you've learned how to put people in a group. Cool. All right. Now I promise in the other book we're gonna beat you to death on what the hell a primary group is and a secondary group. But right now, just nod your head and go, okay. Whatever you say, dude. Okay. So the password command is, basically how you change your password. So there's a password complexity requirements that most systems will use. Did you notice when we created the Bob account, I have a password called Bob, and it did not complain. It didn't come up and say, oh man, that's a horrible password. It's only 3 characters long. There's no special characters or numbers or whatever, like no complexity rules whatsoever. Yeah, I know, it's a little weird. You could, by the way, add user is a shell script. We're going to be dealing with that in a minute. You could go in and alter that guy to have it automatically do the password complexity rules. So the password complexity rules are something that you do, that you set up. And we're not going to do it now because the other book is going to, again, go into a lot more detail. So right now, the password command allows me to change the password. So if I'm root, I can change the password for Bob, for example. Otherwise, the password command just changes it to my own password, which is pretty cool. Okay, moving right along to chapter 10, and we're talking about processes. So you know that Unix, Linux is a multi-user, multitasking operating system. And so one of the things you can do is think about how the system boots up. Okay, so when it boots up, there's a program called init that basically bootstraps the system to fire it on up. And then it runs a whole bunch of shell scripts in this folder called etc. init. So I'm going to go to etc. init. Okay. It's probably going to be initd. Yeah. Yeah, initd. So I'm going to go into initd. Dang it, I can't type today. Whew. So when the machine boots up, it's going to run all this, and it's a lot. Okay, all these things. It's don't worry about what all this stuff is, but green basically means that it's an executable file. And so I'm going to run all these commands that appear in here. And so the machine doesn't wait until one finishes so it starts the other. These things are well scripted. There is an init file, an init.rc file that tells you what order these things have to appear in and all the rest of that kind of stuff. So all these processes are fired up at the very, very beginning. So the very first process, the init guy, has a process ID of 0. It's the very first process in the entire system, and all the rest of them get numbered afterwards. Okay, kind of weird. So I'm going to type the PS command. The PS command basically tells me all of my processes. Okay, well, I only have 2 processes right this very second. I have the shell and the command that I just typed, which is PS. But look, see the number over there, the process ID, the PID, 1839 and 2282. Okay, so as the machine progresses, it produces these processes one at a time. Kind of sort of makes sense? Okay, so if I do PS tree, this will basically tell me, here's all of the processes and how they're related. So system D is a process that starts everything up, and then VBox service, and then an accounts daemon, and then AT, and there's the thing called at, which is like scheduled task, and cron, and and then login, okay? And then a bunch of other stuff going on. So all these things are kind of sort of related. The way it works is a single process like system D can have multiple child processes, and a child can only have one parent process. It kind of makes sense. It's a tree, right? Makes sense. Okay. So the init thing is almost always a ID of either 1 or 0, depending on how the thing is built. Okay, so the PS command is a little confusing because remember how I said that almost all commands have a dash for the options? Well, this is one of those crazy situations where the AT&T folks did it with dashes, and the Berkeley group did it without dashes. And so when the GNU people came along to kind of fix it, they decided, well, we'll just use a long notation. We'll just ignore both camps, okay? And in reality, that's pretty dumb. So I'm going to use PS minus AUX. I'll explain what all that means in just a minute. So this is a listing of all of the processes, what the owner is, the process, all the rest of the stuff. And there's a whole bunch of stuff in here. I probably should have done this through less, so I can see the headings across the top. So the user, the process ID, the amount of CPU it's using, the amount of memory it's using, the amount of virtual space, which TTY it's on. TTY is kind of like the abbreviation for which terminal. Well, like if no terminal is running, like at the beginning, you have nothing, right? That kind of makes sense. But when you get down to me, where I am, it's going to say TTY1 because that's the terminal that I'm on. And this status, and we'll talk about what all that stuff means. Okay, so this is one of those situations where there is no dash, just the A, basically for all users, and then the extra stuff. So AUX is a typical way of doing it. Okay, so this process status part, let's take a minute to look at that because that's got some weird stuff in it. So I'm going to go here and look at what this thing could be. It could be R for running. It could be S for sleeping. D for uninterruptible. Basically what that means is, yeah, I'm sleeping, but you can't stop me. Only thing that's going to wake me is the kiss from the... No. The only thing that's going to awake me is whenever my task is completed. T for stopped. Z for a zombie. Zombies are ones where the machines no longer have been... It's like, remember I said that everything has to have a parent? What happens if I kill the parent and I got these, orphan children over there? And then a little less than sign talks about it's a high priority, and then there's a low priority, and blah, 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 blah. Okay, So that's it kind of sort of in a nutshell of how to read the PS command. Okay, so if you're a geek, you're gonna love this. I'm gonna go ahead and hit like the space bar to get to the point where I can see some of my own processes. Okay, so there's TTY1, that's emit gray, and I'm running the shell command, and I just typed in PS minus AUX. Well, gee, isn't that a surprise? And then now I'm running it through less. So all of my worker threads are shown on TTY1. Kind of makes sense? Cool. All right. How useful is that in your world? Nah, it's kind of hard to say. Am I going to have to learn this? Some of it. Instead of looking at this, typically I don't go here to diagnose a problem. Let's say my machine is running really, really slow, and I've got a runaway process that's just chewing up all my memory or all my CPU, and I want to kill it. I could go here and I could maybe do some sorting or just kind of scrolling up and down trying to find that percent column. That'd be 1, 2, 3, the percent CPU and percent memory, columns 3 and 4. Find one of those guys that's kind of acting up and then whack it. There's another one out there called top. And top command is a weird one. Okay, top does everything. In fact, this is a very fantastic diagnostics tool, and man, we could spend an entire day on what top can do for a living. But top basically tells me everything. It gives me what my runtime is. I've been up for an hour and 1 minute. There's one user logged on, and as you can tell, it's live. So as things change, I can see them change in the top command. So this would be a perfect way to find out what's causing a problem. And there's ways in here, I'm not gonna get into it. There's ways in here where you can stop a process or kill a process just from inside the top command. Kind of makes sense? Okay. So I kind of like the top fields across here, the process ID and the user and the priority and the niceness level. We haven't talked about that yet. Some virtual and blah, 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 blah. Percent CPU, percent memory, how much time's been in running, and then what the command is. If I have a command that's been running for like 5 days and it's chewing up lots of space, I might go, wait a minute. Kind of makes sense? So the top command is kind of cool. I'm going to hit escape, or Q rather, Q to get out of that guy, because he's going to run just like that. Cool beans? Okay. Again, top command is very powerful. I would recommend if you're really going to be getting into the Linux world, learn the top command, because it's an easy way of finding a runaway process. Okay, you guys remember when we used Control-C to stop a runaway process? Remember when we did the tree command? We did the tree command on the root. Remember that? Let's do that again. I'm going to do tree, yikes. Dang it. Tree command like this, and then it went, I say stop. I hit Control-C. Remember that? Okay, cool. So this sending signals to a command to stop or do something else is a kind of a cool thing. Control-C is the only one we've learned so far, but we could do another one. I'm going to do this tree again, and then I'm going to say Control-Z. Now what Control-Z means is I've stopped it, but I could resume it at any time. Control-C means stop. I don't care about you anymore. Go away. But Control-Z is a way of actually stopping something, and then I can pick it up where I left off if I wanted. Ooh, isn't that pretty cool? There's a couple others. One way to do, I'm gonna do this tree command, except I'm gonna have it redirected onto a file, but I'll do that after the start of the next video.